Okay, part 2 then says, hence solve these simultaneous equations, which look quite awful, but we've already changed this into this equivalent quadratic. So instead of using this, I'm going to use the non-log equation instead. Now this is a little bit unusual. We've got a log to the base 2 of something equals 0. Now we need to be asking ourselves what, when we log something, gives us an answer of 0. And the answer is 1. If we do log to the base anything of 1, we always get 0. So that tells me that y minus 10x plus 14 has to equal 1. You can check that on your calculators, but it has to be. That now means we've got two fairly normal simultaneous equations. If I can write this in terms of y, by moving everything over to the other side, so adding the 10x on and taking the 14 away from the 1, so that'll be minus 13. We've now got that y is equal to 2x squared minus 1 and y is equal to 10x minus 13. So that means we can say that 2x squared minus 1 is equal to 10x minus 13. It's another quadratic. Let's move everything over to the left side. 2x squared, take 10x, add the 13 back on is going to turn that into an add 12 is equal to 0. We can make this a little bit easier by dividing everything by 2. And then this will factorise with a minus 2 and a minus 3. So that tells us x is 2 or x is 3. Both of those answers are absolutely fine. They both work for this question. If x had come out negative for one of these answers, we'd have needed to ignore it because you can't log a negative number. And because logs are involved, that would mean we'd have to ignore that option. But we don't in this case. They're both fine. Last job then is to work out what y is equal to. So because y is equal to 10 lots of x take away 13, when x is equal to 2, y would equal 20 take 13, so 7. Or when x is 3, y would be 30 take 13, which is 17. So those are your answers when x is 2, y is 7, or when x is 3, y is 17.